Welcome to ECE 476 Advanced Embedded Systems, lecture number 26. In this lecture, we look at Neopixels. So the goal of this lecture is twofold. First, how to drive the Neopixel on your Pi Pico board. And second, how do you drive an external Neopixel? So, starting out. A Neopixel, also known as a WS2811 or WS2812 LED, are single-wire LEDs. They're RGB LEDs, which is 4 pins. You've got 5 volts, ground, data in, data out. The neat thing about the Neopixels is you can cascade them. Using only a single pin on your Pico, I can drive as many LEDs as I want. And the way you do that is each one gets power and ground, kind of course. Data in on one, or data out on one goes to data in on the next one. The way the Neopixels work is when you send out 24 bits of data, that tells the first Neopixel how bright it's supposed to be. The green, red, blue brightness. From 0 to 255, 0 is off, 255 is full power, about 20 milliamps, and proportional in between. The first Neopixel pulls off the first 24 bits and then passes on the rest. The second Neopixel sees this as the first bit stream, and it turns on, then the third one, fourth one, and so on. The way the Neopixel knows that the end of message has been received is if you're idled for more than 50 microseconds, it thinks the message is over. So that's kind of the idea of how Neopixels work. To do that, you need to send a precise set of ones and zeros. The way ones and zeros are encoded is each bit is 1.2 microseconds, 1200 nanoseconds. The pulse width tells the Neopixel 1 or 0. If the pulse width is 300 nanoseconds, that's interpreted as logic 0. If it's 700 nanoseconds, that's interpreted as logic 1. So, for example, this bit sequence would be 0, 1, 0, 1, based upon the pulse widths. Short, long, 0, 1, 0, 1. Now, how do you do that with Pi Pico? Well, there's a couple ways of doing that. One is the function bitstream. Bitstream is a function inside library machine. It's also inside library Neopixel. As far as I can tell, it's redundant. Same library, same routine. What bitstream does is you tell it which pin I want to send the data out on. The encoding is always 0. It transmits 0 and 1 bits based upon the timing of the most significant bit. The timing tells you what is logic 0, what is logic 1. This has 4 numbers on it. The first one is how long you're high for logic 0, how long you're low for logic 0. Then it's how long you're high for logic 1, how long you're low for logic 1. So to output this timing right here, I would do the numbers 300, 900, 700, 500. So that's what you want to send for timing. The data is, of course, a binary file, binary array of the ones and zeros you want to send out. So for example, suppose I just want to drive a single Neopixel. I want to go red, green, blue, repeat. So here's what it looks like. Let's move this over here so you can see. What the code does is I first have to import bitstream and pin, define the timing, so this is logic 0, this is logic 1, tell it which pin the Neopixel is connected to. On your Pi Pico board, it's connected to pin 12. Then I'm just going to define red, green, blue. 255 is full brightness, so this is 50, green, red, blue, red, green, blue. And then in the infinite loop, I'm going to talk to the pin 12 using normal timing. The timing is right here, and send out this bit pattern, 0, 50, 0, then it goes red, then green, then blue, repeats. And here's what you're seeing. So there's your red, green, blue, red, green, blue. That's sending out a single, well, driving a single pixel. What the signals red, green, blue look like, that's a byte array. So this is the bit pattern. It tells that this is the green color, the red color, then the blue color, 0 to 255. 255 is full brightness, 0 is full off. So that's talking to a single neopixel. Well, what happens if you want to talk to a neopixel array? Well, there's the result. What if you want to drive a bunch of neopixels? Well, in that case, all you need to do is take this guy right here, and instead of making that 3 bytes, make it, in this case, 12 times 3, 36 bytes. And what I'm going to do is make the first neopixel brightness of green, red, blue. So that one's kind of bright. All the rest are kind of dim. If I send this to the neopixel, I'll show you what that looks like. Switch over to Thani. And here for my LED array, I actually have 16. So I'm going to change that number to 16. Run that puppy, and there's your signal. The brightest one, right where my thumb is, this is neopixel number 0, then 1, 2, 3, all the way around. And I can change the color just by changing the numbers that are right to the array. So just for fun, let's make everything more reddish. And it shows up as green because the order is green, red, blue. Okay, try that again. We'll make things more reddish. Be really bright red. There's your red. I want it to be more blue. And so on. If I want to change any neopixel, I make that fourth one a different color. Then the light that I change would be the fourth element, since these are in groups of 3, would be 12 is green, red, blue for element 4. If we run that, this guy right here, element 4, is now brighter green, making it red or blue. Now, kind of a sidelight. When you connect up these neopixels, kind of theme in this class is when you solder up your parts, if you just connect little headers to the parts, then I can run a wire from the header to your Pico board. Another trick you can do is sometimes it doesn't work. That's because you're getting noise on these lines. I've got fairly high frequency signals. If I run a wire along looks like an antenna, one way to keep the noise level down is use a twisted pair. So here's the ground wire black in my data. Twist them and keep the two wires fairly close to each other. So I'm using ground and in this case pin 1 for the data. By doing so make the output pin 1, I'm able to get the data out without as much noise. So that's one way to write to the neopixel using bitstream. If you look at the data that I'm sending, this is the binary file. This is the first LED, first 3 bytes, the second LED, the third LED, fourth LED, and so on. And likewise, what I mentioned, if you want to change the color of any given LED, you can just hard code it right in that array. That's the green, red, blue pattern. Okay, so that's one way to do it. Second way is to use the NeoPixel library. Now there's a library that comes standard with MicroPython called Neopixel. If I import it and look at what's in there, there is Neopixel and bitstream. Bitstream we just talked about. To initialize an I/O pin using the Neopixel library, I will define a a object, np, to be Neopixel and library Neopixel, the pin that I want to use, the number of bits, the type of Neopixel, and the timing. The first one is what pin you're connecting to. In this case, I'm connecting to pin 1. N is the number of Neopixels. I've got 16. The type of Neopixel. There are two different types. There's RGB, that's this one, and some Neopixels actually have a fourth color, white. So this is a 3-color Neopixel, and the timing is, am I running at 800 kilohertz or 400 kilohertz? We'll use 1. For example, this would be what we'd be doing for 8 Neopixels, like the ones in your kit. I'm special. I have 16 Neopixels, and I'm connected to pin 1. So doing that, I've got a couple options within Neopixel. If I do help Neopixel, Neopixel, there are the commands fill, write, and order. What order does is it changes the color to red, green, blue. If there's a fourth one, be white. Basically, take these two pins and shuffle them, so I don't have to go green, red, blue. Red, green, blue is kind of more standard. What write does is it takes whatever's in the buffer and sends it to the Neopixel. And fill is kind of a shortcut. If I want to send the entire buffer to a single color, I can do that. A comment about the Neopixel routine. It uses this timing. So this is logic 0, logic 1. That's close enough that it works on the separate Neopixel arrays. Doesn't work on the 52 Pi board though. So if you want to drive the Neopixel in the 52 Pi board, you need to change the timing, which is using the previous code with the bit stream. For the other ones, you can use Neopixel, and it mostly works. So as an example, let's use Neopixel to light 3 LEDs. I want it to be red, green, then blue. So to do that, I would write this routine. I'm going to import pin and Neopixel. I'm going to be using pin 12, where the RGB LED is. Define my object. I want to start with everybody being off, and then change the 0th, 1st, and 2nd Neopixel to be green, red, blue, then right. What that looks like is this. I run it, zooming in, and you can see that I've got red, green, blue. This is the 0th Neopixel. And the 0th Neopixel should show up here. It doesn't. That's because the timing is off for the 52 Pi board. So I'm not actually going to be using pin 12 anymore because that causes this just to kind of flicker. I'm going to be switching over to pin 1. So changing it so my Neopixel is now connected to pin 1. I've got the remnant of the old code. There's the brightness of the Neopixel, your red, green, blue. Okay, so with that, let's have the LED spin around in a circle. Now to do that, what I'm going to do is create a shift register. In this case, if I have 12 Neopixels, I got 12 elements in the shift register. That's Neopixel 0 through 11. Every 100 milliseconds, I'm going to take all the element in the array and shift it by 1. So here's kind of what the shift register looks like. Element 0 goes to 1, 1 goes to 2, and so on. And 11 comes back to 0. So it looks like the lights just keep on spinning around. In terms of coding, I'll set up the array. I've got 12 lights in my array. I'm going to be connecting to this pin. I will then turn on the Neopixel. Start with 0. Define each element, and then in my shift register, I'm going to take element 10 minus I, copy it to element 11 minus I, go all the way through. Remember the first element, and that goes on the left. Once I've shifted everybody, do a write. So let's see how that works. going over here, same idea with 16 neopixels. If I run it, here's run. You can see the LED spinning around. And there's other ways of doing it. This is one way. Next, let's have the LEDs bounce back and forth. So I'm going to go from 0 to 11, in my case 15, back down to 0. Depends how many LEDs you have in your array. Keep bouncing back and forth over and over again. So one way to do that is I have to tell it how many pixels I have and my direction. What I'm going to do is all the lights are off except for NeoPixel number N. That one's going to be red. I'm going to start shifting it to the right. N's going to count from 0 to 11. If I get to 11, change the direction. Count from 11 down to 0. If I get to 0, start counting up. So you can go 0 to 11 to 0 to 11. And N is the one that turns on. So let's see what that looks like. So here's the bounce. I've got 16 neopixels. Go from 0 to 15, back to 0 to 15. When I run that, doesn't show up real well. Okay, change the color to yellow, so that's 250 red, 250 green, makes yellow light. There you can see the bounce. That's a bouncing light. Finally, let's build a lightsaber. So when I hit the buttons, this is light on, light off. When light on, the lights turn on one by one every 100 milliseconds. On light off, the lights turn off every 100 milliseconds. So in terms of coding, I'm going to have two variables, power on, power off. That's my input buttons. When I power on, I am going to start increasing, and it's going to count up to, in this case, 12 or 16 in my case. That's the number of LEDs that are turned on. When I hit power off, every time I go through the loop, every 100 milliseconds, N counts down. And all the lights are turned on up to N minus 1. So let's try that. Going over to lightsaber code, here I've got 16 neopixels. My two buttons, power on, power off. And let's change this to yellow. I'm not sure what yellow lightsabers mean, but it just shows up better. When I hit the power on button, N counts up, power off, N counts down, and that's how many LEDs are turned on. So expanding that, power on, lightsaber turns on, power off, power on, power off. So that's kind of some of the things you can do with a NeoPixel. So NeoPixels really aren't that hard to use with the Raspberry Pi Pico and Python. And you only have two options. You can use Bitstream. With Bitstream, you have complete control over the on-time, off-time for the logic 1s, logic 0s. If you want to use the NeoPixel on your NeoPixel board, you need to use Bitstream. If you have an external NeoPixel, like the ones I'm using here, you can use the NeoPixel library. That seems to work. When you do that, I send n arrays of tuples, the red, green, blue colors. You'll notice the kind of difference with the NeoPixel library. The sequence is red, green, blue. With the Bitstream, it's green, red, blue. Now the NeoPixel library doesn't work with the NeoPixel on the 52Pi board, but it does work with external arrays. So that's some of the things you can do with Neopixels, some references, and a 52 Pi board with a Raspberry Pi Pico.